Okay, let's take a look at Chapter 1, Lesson 4, proportional and non-proportional. It says two quantities are proportional if they have a constant ratio or unit rate. So a constant ratio or unit rate. We learned about unit rates in Lesson 1. To be constant means it is the same over and over and over again. For relationships in which this ratio is not constant, the two quantities are non-proportional. So proportional, it has to have a constant rate. Non-proportional is not a constant rate. So in the previous page, on page 33, they went over a pizza example. And they have the different rates set up here below. It says the cost of an order is proportional to the number of pizzas ordered. You can see that the number of pizza ordered are down here on the bottom. So one pizza, and then the cost is up on the top. One pizza costs $8, two pizzas cost $16, three pizzas cost $24, four pizzas cost $32, and five pizzas cost $40. In other words, when I divide all those out, 8 divided by 1 is 8, 16 divided by 2 is 8, 24 divided by 3 is 8, 32 divided by 4 is 8, 40 divided by 5 is 8. Each pizza costs $8, so it's $8 per pizza. This is a proportional relationship because all of those ratios above are equivalent. There is a constant rate, constant ratio. So that's what we're looking for. It says Andrew earns $18 per hour for mowing lawns. Is this amount, $18 per hour, of money he earns proportional to the number of hours he spends mowing? Well, let's take a look. We could say that the number of hours, X, and the number of, or the amount of money earned, Y, can be written into a table like this. 1 hour, equals $18. 2 lawns would be $36. 3 lawns would be $54. And 4 lawns would be $72. And so we can see that if I take Y and divide it by X, 18 divided by 1, 36 divided by 2, 54 divided by 3, and 72 divided by 4, that those are all equal to $18 per hour. So yes, this is a proportional relationship. Example number 2 says, Uptown Tickets charges $7 per baseball game ticket plus a $3 processing fee per order. Is the cost of an order proportional to the number of tickets ordered? Okay, so we're trying to find if the cost is proportional to the tickets ordered. So we're going to have to list out a number of tickets. We'll call that our X number, 1, 2, 3, 4. And we're going to see if that cost is consistent or proportional. And we'll make that our Y number. We know that it costs $7 per ticket, so we can multiply 7 times the number of tickets, and then it says plus a $3 processing fee. That's a one-time thing, so that's a constant, so plus 3. This will give us our Y number, so we could actually write this as our function. Y equals 7 times the number of tickets plus a $3 processing fee. So if I plug 1 in to this, we get 7 times 1 is 7, plus 3 is 10. So it would cost $10 to buy 1 ticket. If I purchased 2 tickets, I would plug it in to my function, and it would be 7 times 2 is 14, plus 3 is 17. If I put in 3 for the number of tickets, then 7 times 3 is 21, plus 3 is $24 per ticket, or for the 3 tickets. And then if I plug 4 in for the number of tickets, X, then 7 times 4 is 28, plus 3 is 31. So when I make this little table here, 1 ticket costs $10, 2 tickets cost $17, 3 tickets cost $24, and 4 tickets cost $31. To see whether or not this is proportional, I want to take Y and divide it by X. So I want to put 10 on top and 1 on the bottom, 17 on top and 2 on the bottom, 24 on top and 3 on the bottom, 31 on top and 4 on the bottom. And then I want to check to see, are those equal? 10 divided by 1 is 10. 17 divided by 2, that doesn't divide evenly. But let's go over here to this third one. It says 24 divided by 3 is 8. We can see from this that $10 per ticket and $8 per ticket are different. And since they are different, that means this is a non-proportional situation. It doesn't matter what 17 divided by 2 is, even though that is $8.50 per ticket. It doesn't matter what 31 divided by 4 is, even though that comes out to be $7.75 per ticket, if I did my math right. 28, 3 left over, 3/4 is 75 cents, yes. So it doesn't matter. All I have to do is find one of these ratios to not be the same. So as long as there's 2 different, we know that this is non-proportional. Proportional, they have to be all the same. Non-proportional. Let's take a look at example 3. It says you can use the recipe shown to make fruit punch. Is the amount of sugar used proportional to the amount of mix used? Explain. So they're actually giving you a table here, and I'm going to have to move this down so that you can see it. And it says, using this recipe, is it proportional or non-proportional? Well, we have to look at this and go, okay, what is the X number? What is the Y number? It says we are trying to find if it is sugar to mix. So sugar to mix, that means sugar is my Y number and mix is my X number. They actually have this table made backwards. They have this table made backwards. So when I set up my ratios, I would want to put the 1/2 over 1, 1 over 2, 1.5 over 3, and 2 over 4, so that it is Y over X. Then I have to simplify these. Well, this one is already simplified. This one, 1/2 is already simplified to 1/2. 2 over 4 is also equal to 1/2. So the question is, are the other ones equal to 1/2? We can actually use a little bit of common sense and logic here. What is half of 1? 1/2 is half of 1. So actually, the first ratio is also equal to 1/2. So the question is 1.5 over 3 equal to 1/2? This is a complex fraction, so we could actually go and change it into a simplified fraction by dividing 3 into 1.5. We would first need to change our 1.5 into an improper fraction, which is 3 over 2. and we would divide that by the bottom number, 3, which we would put over 1. We would keep change flip and get 3 over 2 times 1 over 3. Our 3's will cancel out, and you can see that's going to leave us with 1/2. So 1.5 over 3 is also equal to 1/2. So is this a proportional relationship? Yes. All the ratios are constant. All right, let's take a look finally at example number 4 on page 36. It says the tables shown represent the number of pages that Martin and Gabrielle read over time. It says which of the situation represents a proportional relationship between the time spent reading and the number of pages read. It says Martin reads 2 pages in 5 minutes, 4 pages in 10 minutes, 6 pages in 15 minutes. So we actually want to know what is the relationship of time spent to the number of pages. Time spent to the number of pages. So time is my y, and pages is my x. So same thing over here. Time is my y, and pages is my x. This is the way typically we will set up a table where the y is on the bottom, the x is on the top. But then when we do our ratios, we want it to be y over x. So 5 over 2, 10 over 4, and 15 over 6. Over here it would be 5 over 3, 10 over 4, and 15 over 7. And we want to know which one of these relationships is proportional. If I take my calculator and I divide 5 divided by 2, it comes out to be 2.5 minutes per page. If I take 10 and I divide it by 4, I get the same thing, 2.5 pages per minute. And if I do, or minutes per page, and if I take 15 and divide it by 6, it also will come out to be 2.5. You could also reduce those improper ratios to be 5 over 2. That one's already reduced, but 10 over 4, if I divide top and bottom by 2, I get 5 over 2. With 15 over 6, if I divide top and bottom by 3, I get 5 over 2. So you can see they are all equal, making this a proportional situation. And it actually asked which one was proportional, so the answer is Martin's. However, we should go ahead and check this one over here. 5 divided by 3 actually comes out to be a repeating decimal of 1.666666, and your last number on your calculator will be a 7. So it's 1.6 repeating. When you take 10 and divide it by 4, well, that's 2.5. We just found that one out over here on this other one. And when you take 15 and you divide it by 7, you get 2 1/7, which is going to be a really ugly decimal on your calculators. You could see, though, that these are not equal. Those are not equal. So Gabriella's reading rate is not proportional. She does not have a constant reading rate. So proportional, you get a constant ratio. Non-proportional, a not constant ratio. So go ahead and try the 2 letter problems, and we will go over those together in class.